Higher order derivatives, velocity and acceleration. Now we'll extend our applications to these higher order derivatives. Velocity is rate of change of displacement and acceleration is rate of change of velocity. So velocity is first derivative of displacement and acceleration is the second derivative of displacement, right? So that is how we get into higher order derivatives. And let's now try to understand motion of an object along a straight line with the help of these derivatives. So in these set of videos, I'll consider a lot of cases in which we'll consider this motion and see how displacement, velocity and acceleration are related, and then have a set of objective type questions which will help you to do a quick review on the topic. So when you go through those sets of questions, try to answer the questions and move on. And if you have difficulty, then you listen to my suggestions. So that way you learn a lot more. Now here's question number 1. The position of an object on a line is given by s of t equals to 6t square minus t cube, where t is greater than or equal to 0, where s is in meters and t is in seconds. Now in almost all the questions here, s will represent displacement, t time, displacement will be in meters, time will be in seconds, and first derivative of displacement will be velocity, second derivative will be acceleration. Now A, find velocity and acceleration at t equals to 2. When is object at rest? When is object moving in positive or negative direction? Now let's understand this concept. So we know displacement is given to us, which is s of t equals to 6t square minus t cube, and t will normally be considered greater than or equal to 0 as mentioned here. Now velocity is rate of change of displacement. So we write velocity is equals to rate of change of displacement. So we differentiate displacement with respect to time, and when we do that we get 12t minus 2t square, right? Now here we can factor this, and then we can factor 2t, and so we get 6 minus t. So that is an expression for finding velocity in factored form, and this one is your polynomial with 2 terms. Now find velocity and acceleration at t equals to 2. Now when we have to find velocity and acceleration at t equals to 2, you just need to substitute t as 2 here and get the answer. But let's first differentiate again velocity and get acceleration. So acceleration basically is derivative of velocity. So let me first write this as acceleration, okay, as derivative of velocity, which is in fact second derivative of displacement. And that is how higher order derivatives come into picture, right? Now this is the first derivative. So second derivative means find the derivative of the derivative, right? So we'll again differentiate this with respect to t, right? So we can adopt product rule, but this is better equation to use. So we'll use this equation to differentiate velocity and get acceleration. So acceleration will be 12 minus 4t, right? Now 12 minus 4t can be factored, and let me factor right there. It is 4 is taken common here, and we get 3 minus t. Both equations have their own advantages, right? From here you can easily find zeros. So that is a factored form, which helps you when is velocity 0, when is acceleration 0, and things like that. And this equation is better to work with as far as differentiation is concerned or finding values is concerned, right? Now once we have the equation, then we can find velocity and acceleration at t equals to 2. Vt, that means v2 is velocity at 2. So we can plug in the value 2 here and get the answer. So 2 times 2 is 4. So let me write, or let me plug it in here. So we'll write 12 times 2 minus 2 times 2 square. Any equation can be used for that matter, correct? So that gives us the velocity at time t, correct? So what do we get? 24 minus 2 square is 4, 4 times 2 is 8, right? So that is our answer. You can get it from here, or you could have done this substitution right there. So in that case, you'll get 2 times 2 as 4. And here, when you plug in 2 here, you get 6 minus 2 as 4, right? So 4 times 4, 16. So either way, you get the same answer, 16, right? Important thing here is units. When we have told you that the units are meters for displacement and time is in seconds, then it's important to write units as meters per second, since it is derivative of displacement, right? So the units will be meters per second. Now that's velocity at t equals to 2. Now to find acceleration, let's find here. So a at 2, right? At 2 will be equals to, we'll substitute there, 4, 3 minus 2, that is 1, it gives me 4. And the units will be meters per second square, right? Derivative of velocity with respect to time, right? That's how you get your answer. Now the question is, when is the object at rest? Now object will be at rest when velocity is 0. That means we are looking for velocity equals to 0. Now that means velocity expression is given to us, which is Vt is equals to 2t times 6 minus t, right? Now this has to be 0 to find the time when it is at rest, right? So this could be 0 at t equals to 0 or at t equals to 6. Either of the factor could be 0, right? So we get the answer, which is at t equals to 0 or at t equals to 6, right? These are the times, and these times are in seconds. So you should write down the answer in seconds. So object is at rest at the initial position when it's just going to start, and at t equals to 6, right? Now it is from here you should also understand that this is also the time when the object is like turning, right? It's kind of a let me just sketch this for you so that you understand what I'm trying to say. When object will turn, for example, if the object is going like this and it turns, so this is the point at the turning point at which the object will be at rest, okay? Now part C is, when is object moving in positive or negative direction? Now, object moves in positive direction if velocity is greater than 0. So if velocity is positive, that means you are moving in the positive direction. And if velocity is less than 0, then you are moving in negative direction, right? So for that, it will be good if we could just sketch our velocity curve, which is 2t times 6 minus t. So as we saw here, it has 2 zeros, right? So let me just have this curve here. So it has 2 zeros, which is 1 0 is at 0 itself, right? So this was 1 0 at 0 itself, and the other one we found was at 6, right? So these are the 2 zeros for us, and that's the turning point. That's the turning point, right? Now, so the turning point in a parabola will be right in the center of the two, correct? Turning point will be right in the center of the two, right? So what we notice here is that at around 3, exactly at 3 in fact, because parabola has axis of symmetry, the velocity changes. The velocity is positive from 0 to 3 and negative from 3 to 6, correct? Therefore, the object moves in the positive direction from when velocity is positive. So let me use this space here to answer question C, right? So we say positive direction. So we say positive direction is between the interval 0 to 3. And the negative is between 3 to 6. Right? So that is what it means, positive and negative. When object moves in positive direction, then the distance is increasing. The positive direction means displacement increases, right? So we say distance increases. And when the object turns, then it starts decreasing. Do you see that? So that is how the things are related. So you can see now that when velocity is 0, that is the turning point for an object in motion. And when the object's velocity is positive, its distance is increasing from the initial or the origin point or from the point of reference. Now, as soon as the velocity becomes negative, then the object starts approaching the initial position and the distance starts decreasing. So that is how the things are related, and we'll explore more in coming questions. I hope these concepts at least are absolutely clear to you, that displacement is, when the displacement is given to us, derivative of displacement, the first derivative is velocity, second derivative is acceleration, and displacement is closely related with velocity, since velocity is rate of change, and if the velocity is zero, that means the body is at standstill, stationary position, not moving. It also indicates a turning point. When you turn, at that time there is no movement. But before and after turning point, the object could be moving in positive or negative direction. Positive direction means displacement is increasing, negative direction means displacement is decreasing. Positive direction means velocity is positive, negative direction means velocity is negative. So that is how these things are related. I think concepts are clear. Let's move on to the next question. Thank you.